Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I shall welcome to all of you in this session of 10th Science and Technology Part 1st. The topic is Gravitation Part 1st. In this topic, we are going to discuss on gravitation, circular motion and centripetal force, Kepler's laws, Newton's universal law of gravitation, acceleration due to the gravitational force of the earth, free fall and the escape velocity. Let us start with the content. Friends, this topic is very important. We have already get introduced with the gravitation in the previous standards. It's very necessary that you have to recall the things related to this topic that you have already learned. In this chapter, we are going to discuss on the following important subtopics: gravitation, force and motion, circular motion and the centripetal force, and introduction to a scientist. Let us start with the gravitation. Friends, before going to start with the gravitation, we must have to recall few questions, few things. Question 1 is, what are the effects of the force acting on the object? When the force is applied on any object, it can cause the displacement, change in the shape and size of the object. It can also change the direction of the motion of the object. These are the effects of force on the object. What are the types of forces that are you familiar with? The types of force known to me are muscular force, mechanical, gravitational force is there, magnetic force is there, frictional force, and the electrostatic force. Third question that should arise, we should have to recall, is what do you know about the gravitational force? The force which is applied by the earth to pull objects towards itself is nothing but a gravitational force. So these are the simple things that we must have already learned and we have to recall before going to start with this topic. We have seen in the previous standards, just we have been discussed all these things. That is, gravitational force is a universal force and it acts only between two objects on the earth, but also between any two objects in the universe. Let us now learn how this force is discovered. So, gravitation. As we have learned, the phenomenon of gravitation was discovered by Sir Isaac Newton. As the story goes, he discovered the force by seeing an apple fall from a tree on the ground. He wondered why all apples fall vertically downward and not at an angle to the vertical. Why do they not fly off in a horizontal direction? So, for an instance, we are going to consider over here the only, that is the apple. The force with which earth attracts any object is directed towards the center of the earth. At any given position of a falling object, the direction from the falling object to the center of the earth is vertically downward. Hence, any object on earth will fall vertically downward and not at an angle to the vertical, nor will the object fly up in a horizontal direction. So after much thought, he came to the conclusion here that the earth must be attracting the apple towards itself, and this attractive force must be directed towards the center of the earth. So that direction from the apple on the tree to the center of the earth is the vertical direction at the position of the apple, and thus the apple falls vertically downwards. Here, this figure 1.1 shows the concept of the gravitational force and the gravitational force between the earth and the moon. Friends, here in this figure 1.1, on the left shows an apple tree on the earth. The force on the apple on the tree is towards the center of the earth, that is along the perpendicular from the position of the apple to the surface of the earth. So the figure also shows the gravitational force between the earth and the moon. Here is the moon and earth. Here the apple falling downward direction. The distance in the figure are not according to the scale. One have to be considered over here. Newton thought that if the force of the gravitation acts on the apple, on the tree, at a different heights from the surface of the earth, can it also act on the objects at even greater heights, much farther away from the earth? Like for example, the moon. Can it act on even further objects like the other planets and the sun? Here the answer we could say that it is yes. Now, force and the motion. We have seen that a force is necessary to change the speed as well as the direction of the motion of an object. So let us recall, let us memorize, let us recall the things that we already learned, that what are Newton's laws of motion. In all, we have seen the three Newton's laws. Newton's first law of motion was an object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. This is Newton's first law of motion. Now Newton's second law of motion was the rate of change of momentum. The rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. Now Newton's third law of motion, it is every action force has an equal and opposite reaction force which acts simultaneously. Third law is every action force has an equal and opposite reaction force which acts simultaneously. So friends, these are the Newton's three laws of motion that we must know before we are learning the next concept, circular motion and the centripetal force. Friends, we have to try an activity. Here you could see the figure. What it is that tie a stone to one end of the string. Take the other end in your hand and rotate the string so that the stone moves along a circle as shown in this figure. Here you can see the stone is moved in a circular manner. 1.2a, this figure. Are you applying any force on the stone? In which direction is this force acting? How will you stop this force from the acting? What will be the effect on the stone? Are you applying any force on the stone? Yes, I am applying a force on the stone, surely. In which direction is this force acting? This is the second question. The answer will be the force is acting in the direction towards the center of the circle along which the stone is rotated. Third question, how will you stop this force from acting? Friends, this force can be stopped from acting by releasing the string. Last one, what will be the effect on the stone at that time? The stone will fly off along a straight line tangential to the circle at the position of the stone, then the string is released. Here friends, it is expected that the angle between the radius of the circular path and in which direction the stone is released is 90 degrees. As long as we are holding the string, we are pulling the stone towards us, that is towards the center of the circle, and are applying a force towards it. So the force stops acting if we release the string. In this case, the stone will fly off along a straight line, which is the tangent to the circle at the position of the stone when the string is released, because that it's the direction of its velocity at that instant of time. That is, here you could see the stone is released here. Here it is the radius and here it is the way in which the stone is moving. So here the angle is 90. Here also if the stone is released from this position, here also you could see the angle, it is 90. You may recall that we have performed a similar activity previously in which a 5 rupee coin kept on a rotating circular disc flies off the disc along the tangent to the disc. In the last year, in the 9th standard, we did this activity. So friends, thus a force acts on any object moving along a circle and it is directed towards the center of the circle. This is called the centripetal force. The centripetal means center seeking. That is, the object tries to go towards the center of the circle because of this force. You know that the moon, which is the natural satellite of the earth, goes around it in a definite orbit. The direction of motion of this moon as well as its speed constantly changes during this motion. Do you think some force is constantly acting on the moon? What must be the direction of the force? How would its moon have been if no such force acted on it? Do the other planets in the solar system revolve around the sun in a similar fashion? Is similar force acting on them? What must be its direction? Friends, very nice questions are these. The first question here is that do you think that some force is constantly acting on the moon? Yes, there is a force constantly acting on the moon known as the centripetal force. The second question is what must be the direction of this force? The second question is what might be the direction of this force? The force is directed towards the center of the earth here. And the third question is how would its motion have been if no such force acted on it? If there was no force acting on the moon, it would have moved along a straight line, which is the tangent to the circle. And the fourth question, do the other planets in the solar system revolve around the sun in a similar fashion? Yes. The answer is yes. Other planets revolve around the sun in the similar fashion. And the last question is similar force acting on them? What must be its direction? Friends, the other planets revolve around the sun in the similar fashion due to the centripetal force exerted on them by the sun. So the direction of the force is towards the center of the sun. From the above activity, or this example and questions, it is clear that for the moon to go around the earth, there must be a force which is exerted on the moon, and this force must be exerted by the earth, which attracts the moon towards itself. Similarly, the sun must be attracting the planets, including the earth, towards itself. Friends, let us see a famous scientist. Just let us get introduction of him. He is very well known scientist, that is great scientist Sir Isaac Newton, born in 1642 and passed away in 1727, was one of the greatest scientists of the recent times. He was born in England. He gave his laws of motion, equations of motion and theory of gravity in his book Principia. Before this book was written, Kepler and given 3 laws describing planetary motions. However, the reason why planets move in the way described by Kepler's laws was not known. Newton, with this theory of gravity, mathematically derived the Kepler's laws. Friends, in addition to this, Newton did groundbreaking work in several areas including light, heat, sound and mathematics. He invented a new branch of mathematics. This is called calculus and has wide-ranging applications in physics and mathematics. He was the first scientist to construct a reflecting telescope. So friends, I think you've gone through all these things. Thank you for watching this video. Let us meet in the next video. Till that, bye.